All right, good morning. Welcome back. This is Mr. H Math Academy bringing to you lesson 10-2. It's 7:15 in the morning, so please don't mind if I have a sip of coffee while I do this. Okay, so today's lesson's about multiplying fractions by whole numbers. Trying to think of a good way to explain this to you guys. I think what we're trying to do here is we're going to multiply these fractions and then we're going to bring everything back to unit fractions. So that's kind of the whole point, I think, is just to, again, look at how this multiplication of fractions is related to the overall idea that multiplication's repeated addition and that we bring everything back to kind of the unit fraction idea. So here's an example. The question says, here's the question. I'll show you this one. It says, how is multiplying 4 times 2/3 cup of juice related to multiplying 8 times 1/3 cup of juice? Okay, so let's take a look at that. So here we go. Here's 4 times 2/3. Now, if you remember from last week, when we multiply this type of problem, your denominator stays the same. You simply multiply the whole number times your numerator. So in this case, it would be 8/3. Okay? And then they want to know how this is related to this. Can you see by looking at this how these two things are connected? We can take this down to a unit fraction. So basically they're pulling this number out, leaving the 1, and then you can still multiply it. Remember, this would look something like this. 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So all they're doing right now is having us go back and forth between solving a problem and then pulling it apart again and showing how it's related to the unit fraction. That's pretty much this whole lesson, okay? So let's look at another one. This is page 549 in your book. If you want to pull your book out, you can look at it with me. Okay, let's look at another problem. So this is page 551. I'm looking at where it says another example. So this one right up here. Saying calculate 4 times 3/5 to determine how far Jess bikes to and from work in 4 days. Okay. So here's the big problem as a model. So here's 3/5. Remember, they said 4 of them. So here's 1 3/5, 2 3/5, 3 3/5, 4 3/5. So if you multiply that, it's going to look like this. So you're going to take 4 times 3/5. Well, when you work that out, here's the book again. You multiply that out, you're going to get 12/5. Sorry about that. So then they want to know how is this related to 1/5? Well, take 12 out. If you take 12 out and we want to write it as a multiplication problem, you would write it like this. So when you look at your picture again, you look at the top section of this model, every 3/5 has been broken down into 3 separate 1/5 parts. So if you add those up, there's 3, 3, 3, and 3. So 3, 6, 9, 12/5 is the same as 4 times 3/5. It's just practicing renaming fractions. It's just sort of getting used to playing with the numbers a little bit, breaking them down, rewriting them another way. But since it's multiplication and addition, you can add in any order. You can break these things down in another fashion. So this part here just shows you that 3/5 plus 3/5 plus 3/5 plus 3/5 plus 3/5 equals 12/5. Or if you remember that's an improper fraction, you can turn it into a mixed number. Remember how to do that. How many 5s can you take out? Took 2 5s out and you had 2 left over, so 2 2/5. Okay, this is how they would show the multiplication part. So, all right, we got 4 times 3/5, and they just wrote it as a multiplication problem above the numerator. So it's really not that tricky. It's just the way they're showing it. It equals 12/5, or you can simplify it or rename it as a mixed number, 2 2/5. Okay, that's kind of what we're doing here. Let's look at the next problem right here. Draw a picture to explain why 3 times 2/5 equals 6 times 1/5. So if we follow the sample that we just looked at, it will look like this. So let me write that. So 3 times 2/5, and they want to know why that equals 6 times 1/5. Well, let's start out with this part first. So they're saying you got 3 of those. I'm going to separate this. Okay, so if this is 2/5, 2/5. So there's 2/5, there's 2/5, there's 2/5. So for each one of those, you would have 1/5, 1/5. Then this would be 1/5, 1/5. Then this would be 1/5, 1/5. So how many fifths do we have now? 1, 2, 3, 4, 5, 6. That matches up with this number right here. So now, all we did was rename it. If you multiply all this out, it equals the same thing, doesn't it? So 3 times 2 is 6/5, or 6 times 1 is 6/5. What does 6/5 equal? Remember, you can't leave those as that. You take out 5, so that would be 1 whole, and you're left with 1 left over. So 1 and 1/5 is the same as 6/5, which is the same as 6 times 1/5, which is the same as 3 times 2/5. It's a lot of circular talk. That's really what it is. That's what makes it confusing, because we're kind of going around in a circle here. But it's just being able to look at these fractions and be able to understand that they are made up of smaller parts. Okay? All right, let's try a couple more. So this whole lesson is about using models. So being able to draw the picture that shows what we're talking about here. So let's look at another model. I'm just going to do a couple of these problems from the book. So this is all on page 551. So then they give you, 1, 2, 3, 4, 5. So they give you some more of these. Now these are not cut into eighths, even though it represents an eighth. This is not the whole part. This is just a section of eighths. So here's some eighths. How could you write that as a multiplication problem? Well, how many do you have? 1, 2, 3, 4, 5. So you have 5 1/8 pieces. What does that equal? 5/8. Okay? That's all it's showing here. Here's another one. Here's, these are tenths. So if this is 2/10, and this is 2/10, and this is 2/10, how many 2/10 pieces do we have? 1, 2, 3. So you could write a multiplication problem that looks like this. Well, if you have 3 2/10 pieces, I mean, you could just add those up if you wanted to also. So 2, 4, 6, or 3 times 2 is 6. You could write it like this, 3 times 2 over 10, which equals 6/10. Okay? That's pretty much it. Let's look at this number line one. Personally, I think the number line ones are more confusing than the other ones, but that's just my personal opinion. So what are we looking at here? We got these pie plates, and there's two pieces left, but how many are in the whole thing? 1, 2, 3, 4, 5, 6. So we're talking about 2, 6, right? 1, 2, 3, 4, 5, 6. So 2, 6. So this is 2, 6, and that's 2, 6. So there's 2, 6 pieces. So I would try to figure out what's going on with this number line here. 2, 6. Let's see if we can do a multiplication equation with that one. So I have 2, 6. So 2, 6, and 2, 6. That means this is 1, 6, this is 1, 6, this is 1, 6, and this is 1, 6. So you could do it this way. What's 2 times 2, 6? That equals 4, 6. Oh, I see. That was what I was doing there. Okay, and then, or you got 4 1/6 pieces. That would equal 4, 6 as well. Okay? That's for the pie one. I was thinking that number line was going with those pie pieces, but they don't. That's a whole separate problem. So let's look at that number line problem. Sorry if that was a little confusing. I thought the number line went with the pies, but it doesn't. Okay, so this one, it looks like they're going by 2/3. So how many 2/3 are there? 1, 2, 3, 4. There's 4 2/3. So if you do 4 2/3, it's like 4 times 2/3 equals, what does that equal? 4 times 2 is 8/3. So if you look at that number line, it says it stops at 2 2/3. Well, that's unusual. It's not unusual. What do you think about that? If that's 2/3, and that's 2/3, and that's 2/3, and that's 2/3, how do they end up with 2 2/3? Because I was thinking, well, that's 8/3, right? Isn't 8/3 an improper fraction? What does 8/3 equal? How many 3's can you take out of 8? You can take out 2. And how many would be left? 2/3. So that's why that number line ends up at 2 2/3. Okay? If you have any questions, you know you can email me. Make sure you're working on the assignment on Envision, please. And have a good day. Bye.